All right, the first unit we're going to talk about here is kinematics in one dimension. When we're talking about kinematics, we're talking about the study of motion, and even more specifically, the how of motion. How can we describe how things move? And when things move, they move through space and they move through time. And if we think about space, we have three-dimensional space, in and out, up and down, left and right, and then through time. So the most complicated way of looking at it is space-time in the four dimensions as it exists. We're going to keep it a little more simple and start with the classical mechanical view that goes back to Galileo and Newton, the 16th, 17th century, age of enlightenment, scientific reasoning. This is where the rudimentary experiments that describe how the world moves, how things move through the world comes from. So we're going to start with cases of one dimension to keep it simple. So if we think about one-dimensional motion, we're moving in a certain position back and forth over a certain period of time. So let's look at how we can establish our position, which is where we are in space in one dimension. So we start with the fact that we're going to use x to represent position, and we're always going to have the need for an origin or a reference point, if you so to speak, as where we start. And we're going to measure to the right is positive, to the left is negative. So I can either move to the right or I can move back to the left, either positive or negative position. So two ways we can view how far we move through space. The first is a certain distance we travel. Distance is related to what, say, your car odometer would read if you were driving somewhere. It doesn't matter where you start or where you finish, just how far you went. So let's say you start here at position 0, and let's say you walk to McDonald's because you're hungry for lunch, and let's just say McDonald's is 2.4 kilometers to the right of your house. Then you grab your McDonald's and you want to go to your buddy Frankie's house. Frankie lives back on the other side of McDonald's, so you travel back to his house, which happens to be 1.8 kilometers to the left of where you started. So how much distance did you travel from where you started to when you got to Frankie's house? So you would say, well, I started at position 0. I moved to position 2.4, so the first length I went is 2.4. Then I walked back to my original position, which is another 2.4 kilometers. And then I went from there 1.8 kilometers to Frankie's house. Notice I'm using kilometers. We do use the metric system exclusively in physics. So I'm not using miles. So what was the distance that I traveled? Well, 2.4, 4.8, 5.8, 6.6 kilometers. That was my distance. And we're going to use little d to represent distance. Well, the other way I can look at where I move or how I move through space is via displacement. Displacement takes into account my change in position. So from where I started to where I finished, what was my change in position? So we use delta x, x is for position, as our displacement. So I started at position 0. I went to McDonald's, back to where I started, and then over to Frankie's house. So my final position, x final, is negative 1.8 kilometers. Okay. My initial position, x initial, is 0. So my change in position, or my displacement, my final minus my initial position, is negative 1.8 minus 0. Or negative 1.8 kilometers. So notice, distance and displacement, very different things. Okay, so we've got to make sure we clarify between the two. So that's your first introduction to kinematics. Oh, also SI units that we're going to use are meters. So sometimes you'll have to make some conversions. So let's say we want to know in meters what this was. Well, 1,000 meters is 1 kilometer. So if I have 1.8 kilometers, I'm going to have to, or 6.6, let's do that over here. 6.6 kilometers. If I want to go to meters, I got to multiply by 1,000, cancels my kilometers. I walked 6,600 meters. And that's your introduction to kinematics and distance and displacement.